When systems collapse, most places react. They go into crisis mode, they panic, they try to fix what's broken. But some regions don't react at all. They just absorb the shock. They slow the damage. They keep functioning, sometimes for weeks or months longer than expected. Why? It's not because they're stronger, or because the people there are smarter. It's because they're built differently. In this video, we're going to look at the regions that are designed, completely by accident, to survive a system collapse. This isn't about prepping or having a secret bunker. It's not about control. It's about structure. And once you understand what that structure really is, you'll never look at a map the same way again. Think of every system collapse as a massive stress test. It's like putting the whole world on a shaky table and seeing what falls off first. A collapse reveals exactly what was overbuilt, what was fragile, and what depended on a constant stream of inputs just to keep going. Most of our modern world, from cities to supply chains, is optimized for one thing: efficiency. Getting things done as fast and as cheap as possible. Very few places are optimized for resilience. And let's be clear, resilience isn't a mindset. It's not about being flexible or thinking outside the box. It's about physical design. It's about how a place is wired, plumbed, and connected. The regions that have a natural ability to survive a collapse tend to share 4 key traits. First, they have redundant systems. This means there's more than one way to move essential things like fuel, food, and power. If one highway gets blocked, there's a network of secondary roads. If one power line goes down, there are other sources to draw from. It's having a plan B, C, and D built right into the landscape. Second, they have local production. They don't just consume. They generate at least part of what they need right there. This could be regional agriculture that feeds the local population, small-scale energy production, or local manufacturing. When long-distance supply chains snap, these places can fall back on their own resources. They have a buffer. Third is low synchronization. This is a crucial one. It means their critical systems aren't all perfectly linked together, so they don't all fail at once. In a highly synchronized city, a power grid failure can instantly knock out water pumps, traffic lights, and communication networks. It's a domino effect. But in a less synchronized region, one system failing doesn't automatically trigger a cascade. The failure is contained. And fourth, they have spatial slack. In simple terms, distance, space, time buffers. Things are more spread out. A problem in one area doesn't immediately affect the next. This creates a natural delay, a buffer zone that slows the spread of chaos. These regions don't avoid failure. Nobody does, but they delay it. And in a collapse scenario, delay is everything. It's the time you need to adapt, to figure things out, to reorganize. So, when you start mapping infrastructure resilience and looking for these 4 traits, certain types of regions begin to stand out. We're often talking about interior regions, away from the crowded complex coastlines. Places with decentralized power grids, strong regional agriculture, and fewer critical choke points like major bridges or tunnels that can paralyze an entire area if they fail. In these places, collapse doesn't happen cleanly. It's not a switch that gets flipped from on to off. They degrade slowly, and that slow degradation is the key. It allows for adaptation. It gives local communities a chance to gain control of their situation. It allows for order to be maintained without resorting to force because people have time to adjust to the new reality. This is where a widespread collapse loses its momentum. It hits these resilient pockets and slows down. On the other hand, many of our most advanced and successful regions fail for the exact opposite reason. Not because of chaos, but because of optimization. They are built for high throughput. They rely on just-in-time logistics, where supplies arrive exactly when they're needed and not a moment sooner. There is zero margin for error. So when one critical node fails a port, a data center, a distribution hub, everything downstream follows like dominoes. These places aren't weak. They're brittle. They're strong right up until the moment they shatter. Collapse doesn't ask where you'd prefer to be when it happens. It asks where you are when the systems that have been compensating for fragility finally stop working. By the time the failure becomes obvious to everyone, when the panic starts, movement is already restricted. Your location has already determined most of your options. Now, this isn't about spreading fear. It's about understanding the mechanics of our world. It's just about looking at the map with new eyes and seeing why some places will keep working when others stop. If this analysis helped you see the world a little differently, consider subscribing. This channel is dedicated to mapping where systems break, where they bend, and where survival becomes possible. Now I want to hear from you. Looking at where you live, is your region built to adapt, or is it built to fail fast? Let me know in the comments below. This is Zero Hour Atlas. We don't predict doom. We map what survives.